Hello. Today I'm going to talk about TOPSwitchGaN. As the name suggests, it's a combination of our TOPSwitch technology with a gallium nitride switch. TOPSwitch has been very successful in the marketplace for 30 years because of its simplicity. Here I've drawn a simplified diagram of a TOPSwitch circuit. We have an input filter, a power transformer, an output rectifier diode, more about that in a minute, an output filter, and a feedback network that uses an optocoupler and a precision reference to provide information about the output to the primary side. On the primary side of the circuit, we have the TOPSwitch IC with a controller and integrated PowiGaN switch. So the key advantage of a TOPSwitch power converter is simplicity. We're using an output rectifier diode rather than more sophisticated synchronous rectification. We have a very simple feedback network using an optocoupler rather than something more exotic. And these features, along with the control engine in the TOPSwitch IC, allow us to provide very simple, very efficient and very reliable operation. Many applications for TOPSwitch will require 12 volts or 24 volts outputs. And for those kind of applications, the use of a diode provides good efficiency without burdening the circuit with additional cost. The GaN primary switch allows us to process more power than we're able to do with conventional MOSFETs. And this allows us to raise the power output of the device. Let's talk about that. With respect to power delivery, if we look at what's achievable today and what the PowiGaN device in the TOPSwitch can provide for us, we can see some very interesting changes in what we can do with a flyback. So if I draw a graph, so this is efficiency, percentage, and this is output power. The TinySwitch 5, introduced by us last year, is a very similar basic circuit. It can go from 20 watts to perhaps 190 watts. That's using a conventional silicon MOSFET. However, with a GaN switch in the TOPSwitch, we can not only increase efficiency, but we increase power delivery significantly. This perhaps is 40 watts. This power level for a flyback converter can now go out as far as 440 watts, while achieving an efficiency of up to 93%, compared to perhaps 91% for a conventional flyback using silicon transistors. Now, the advantage of 440 watt power capability in a flyback converter becomes apparent when we start looking at how that is achieved today. Typically above about 200 to 250 watts. This would be the domain of two switch converters, either half bridges or forward converters, or possibly even a Resonant LLC circuit. These circuits work very well. We see lots of applications where those are required. But now it allows us to move the flyback technology into the power range traditionally reserved for these more complex and therefore more expensive circuits. We have reliability because of the simplicity of the circuit. It's very cost effective. Because we're using simple diode rectification and simple feedback techniques, the circuit also provides high efficiency. Up to 93% full load efficiency, which by the way remains flat across the load range because of the switching algorithm in TOPSwitch. We are also able to extend the power range. Up to as high as 440 watts. This increased power allows flyback now to be an option for applications traditionally reserved for forward converters and resonant circuits. And finally, the TOPSwitchGaN provides the protection features you come to expect from power integrations. Input, line, under voltage and over voltage. Output, OVP, over temperature, and short circuit protection. To find out more about the TOPSwitchGaN family, come and visit us on the web at power.com.